Good afternoon, teacher. I'm Zhou Junyi and I'm MBT2409018. Today, I'm here to deliver my Calculus A presentation. First of all, I would like to talk about applications of derivatives in economics. In economics, derivatives help us understand how a quantity changes. For example, how much more revenue we can earn by selling one more product. That is called marginal revenue, short for MR. Derivatives are used to measure marginal values, such as marginal cost, marginal revenue, and marginal profit. These help businesses make decisions about production, pricing, and efficiency. And a key distinction are average revenue AR versus marginal revenue MR. Average revenue AR is the total revenue divided by the number of units sold. AR equals to TR over Q. It tells about how much revenue we can earn per unit. Marginal revenue MR is the additional revenue from selling one more unit. MR equals to DTR over DQ. It shows how revenue changes as quantity increases. AR and MR. In a competitive market, AR and MR are equal, and both are constant. But in a monopoly or imperfect market, MR is lower than AR because selling more requires lowering the prices. This is why the MR curve is always below the AR curve. Businesses compare marginal revenue with marginal cost to make decisions. If marginal revenue is still higher, it's profitable to keep going. But if it drops below cost, they should stop. Aspect, average revenue, and marginal revenue. What it shows, AR shows revenue per unit, and MR shows additional revenue from one more unit. The usage of AR is to measure prices value level, and the usage of MR is to help find profit maximizing output. In perfect competition, AR equals to MR equals to price, or MR is constant. In monopoly, AR is always greater than MR, and MR falls faster due to lower price needed. Now I will introduce you two examples. First example, suppose the total revenue function is TRQ equals to 100Q divide 2Q squared. Then AR equals to TR over Q equals to 100 divide 2Q. And MR equals to DTR over DQ equals to 100 divide 4Q. When Q equals to 10, AR equals to 80 and MR equals to 60. MR is lower than AR. That tells us the extra revenue is decreasing with each extra unit sold. Let's go to the next example. Suppose that TRQ equals to 500 divide 10Q divide 5 squared. At Q equals to 5, MR equals to 0. But if Q is bigger than 5, MR becomes negative. That means selling more beyond Q equals 5 actually reduces total revenue. This is an example of overproduction in economics. In conclusion, AR tells us the level of revenue, and MR tells us the rate of change of revenue. Both of them are very important, but MR is the key to maximizing profit. Now I will talk about the intermediate value theorem. If a function is continuous on a closed interval AB, and if a number n lies between fa and NFB, then there exists at least one point C in AB such that FC equals to N. In simple terms, if a function is continuous from one point to another, it must pass through every value in between. Now I will give you an example. Suppose fx equals to x to the power of 3 divide 3x plus 1. f0 equals to 1 and f1 equals to minus 1. Since fx is continuous and 0 lies between 1 and minus 1, there must exist a number c belongs to 0, 1 such that fc equals to 0. This tells us that the equation has at least one root in 0, 1. Now I will explain why IVT is very important. First, it's root finding in equations. IVT provides the theoretical guarantee that a root exists before we use numerical methods. It is the foundation of bisection method, a common algorithm in computer programs to solve nonlinear equations. Second, in economics field, IVT is used to prove that equilibrium prices or quantities exist. For example, if demand is greater than supply at one price and less than supply at another price, then a market clearing price must exist in between. Third, in the engineering and physics field, IVT is used to find thresholds, transition points, or when a system changes state. For example, if a machine overheats above 100 degrees Celsius and is cooled at 90 degrees Celsius, then there must be a time when the temperature is exactly 95 degrees Celsius. Here I will introduce you IVT's deeper meaning. IVT connects continuity with guaranteed outcomes. It gives us confidence that solutions exist even when we can't see them. It is the logical foundation for many numerical, scientific, and economic applications. In short, the intermediate value theorem tells us if something changes smoothly and goes from point A to point B, it must pass through every point in between. This is a powerful idea that helps us in math, science, and decision making. In summary, derivatives help us analyze economic behavior through marginal changes. Average and marginal revenue provide different insights for decision making. The intermediate value theorem guarantees that continuous functions don't skip values. Both concepts show calculus is essential in understanding economics. Thank you.
Bye bye.